In this video of geometric sequence and series, I'm going to tell you or show you where and what it is. Now, geometric sequence is also a sequence of numbers, and if we start with the first term a, our geometric sequence is then the first number is always multiplied with a certain constant value. Let's call it r. So if I multiply that, my second term will then be AR. I will then multiply for my third term, and this will become then A times R, which is AR squared, times R will be AR cubed, and so it will go on. Let's put one more. So, to quickly look at what we're going to have, this is going to be my first term, second term, third term, fourth term, fifth term. So you can see then that my nth term, if I want to see what's my nth term, any number, what's the thing? It's AR, and again, can you see that 5? My fifth term is 5 take away 1, which is 4. 4 take away 1 is 3. 3 take away 1 away is 2. So this one will be AR n take away 1. And that will be my nth term. So we can have a general rule saying that Tn equals ARn minus 1. So again, this is the only thing that you have to remember, that the nth one is that formula. The series, remember, series is just the sum of all these terms. This is what you have to remember, and I'm going to do the same as with the previous video. I'm going to write down what the sum is. I'm going to say the sum of the nth term equals A 1 minus Rn divided by 1 minus R. That's all you have to know. For those who don't mind, you can stop the video now. For those who are interested in math, I'll quickly show you where that comes from. Now, before we get to this, it's a basic property of polynomials that if I have x to the power n minus 1 and I divide that by x minus 1, that the answer equals x to the power n minus 1 plus x to the power n minus 2 plus carry on until I get to x squared plus x plus 1. So this is a property of polynomials. Now let's go back to my geometric sequence. If I find the sum of these, so if I say the sum of n equals AR n minus 1 plus AR n minus 2, that's the term just before that one, plus, and I carry on, doikie, plus, and we get to AR to the power, and I'm going to skip all of those, 2 plus AR to the power 1 plus A. And I take out A as a common factor, I'm going to be left with R n minus 1 plus R n minus 2 plus R squared plus R1 plus 1. Now, can you see that this resembles that? Okay, so this resembles that. So I can then say Sn equals A multiply by, and this looks exactly the same as that, which means that this must be a polynomial, and that will be then R instead of X. That would be n minus 1, that is n, take 1 over X, or which is R minus 1. Now, what's the difference between this one and this one? The only difference is you can use any one of the two. This one we're going to use when R, the absolute value of R, is greater than 1. And this one we're going to use if the absolute value of R is less than 1. In other words, if R, when negative infinity is less than R, that's rubbish. It just means if it's greater than 1 and less than negative 1. We're going to use the 1 in front if R lies between negative 1 and 1, which means it's a fraction. So between -1 and 1 when it is a fraction.